Hi guys, today we'll be talking about wave equation. But first of all, welcome to concept mastering. So today we're talking about wave equation. Now, let me give you the wave equation. We have y is equals to a sine bracket wt minus kx close bracket. Now, this is why my term students. The reason why you are finding it difficult for physics is you don't know the basic concept. You don't know the basic concept. In today's class, I will give you many wave equations, and I'm going to show you how you are going to get it. Now, the very first wave equation we have here is our y equals to a sine bracket wt minus kx, where your y is equals to your vertical distance in meter, and your x is equals to your horizontal displacement and your t is time, which is measured in seconds. Your w is 2 pi f, which is your angular velocity. Your k is equals to 2 pi all over lambda, which is your wave number. So, as I said earlier, I'll be listing so many wave equations and I'll be show you how we are going to derive it. Now, listen attentively. Now, note this. Note, before I proceed, also know that your A is equals to your amplitude. Now, note that your F, which is your frequency, is equals to 1 all over T, capital T. Your T here is your period. And also we know that our V is equals to lambda times F. This velocity equals to wavelength times your frequency. If you make your frequency the subject of the formula, you are going to have your F is equals to V all over lambda. Now listen attentively. From this very equation here, if you substitute F equals to 1 all over T in this one, we are going to get our V is equals to lambda all over T. That means when F is equals to 1 over T, you just put it here. We are going to have lambda all over T. Now, I told you guys earlier that our W is equals to 2 pi f. If you substitute this F equals to 1 over T in this formula here, you will have W is equals to 2 pi all over T. Also, if you substitute F is equals to V all over lambda in this formula here, you will have W is equals to 2 pi V all over lambda. Now, At this point now, you can see our W is equals to 2 pi f, and also equals to 2 pi all over t, and also equals to 2 pi v, 2 pi times v all over lambda. This very first one, this is the first one, and this is the second one. In this second one is when f is equals to 1 all over t. If you substitute f all over t in this one, you're going to have 2 pi all over t. If you substitute f equals to v all over lambda, in this equation you will have 2 pi v all over lambda. And you can see that our f is equals to 1 all over t and also equals to v all over lambda. Take note of this. Take note of this. Take note of this. Now, I will tell you this, and I will tell you this is the truth about physics. And this is what I tell my students. Master the concept. Master the concept. If there is any course or subject you should fail, it should not be physics. I tell you, physics is the simplest subject. Physics is the simplest subject. Ever since I was in secondary school, I always have A in my results. And due to because I know all these little concepts. Now, from all these small formulas I've given you, I will give you other wave equations, and they are all gotten from all these formulas here. When you substitute some of these formulas into this very first wave equation, it will give you other wave equation. Just listen attentively. Listen attentively. So we go on. We go on. Now, let's say put W equals to 2 pi v all over lambda. Let's take this our equation 1 here. This is our equation 1. Equation 1. Put 2 pi v all over lambda in equation 1. Equation I. And also put your k. Put your k. Or substitute. You can use put or use substitute. Put your k equals to 2 pi. Use the word substitute. You can use substitute, you can use put. Anyone that suits you. Still the same thing. Put or substitute k equals to 2 pi all over lambda in equation I. Now, listen attentively. When you substitute w equals to 2 pi v all over lambda in this very equation and substitute k equals to 2 pi all over lambda in the first equation, what we are going to have, we have our y is equals to a sine 2 pi v all over lambda. At this very first one here, we have w. When you see w, you put your 2 pi v all over lambda times your t here. This is your t. Times your t. We go on minus, where we see k, you put 2 pi all over lambda. 2 pi all over lambda times our x. Our x, we have times x, close bracket. Can you see? At this very first time, at this point, you're able to derive our second wave equations from all these small formulas here. It's very simple. It's very simple. It's very simple. This is what I tell my students also. Don't cram formulas. Know how to derive it. Once you know how to derive your formulas, I bet you will never forget. You will never forget. This is my first time of this question about this. I didn't learn this in anywhere. I just find my way to figure out these small formulas. And I tell you, you can't find this anywhere. You can't find it. I've checked both YouTube and this thing, other materials, to be able to derive this in such a way that it will be easy for students. I couldn't find. I was able to come up with this idea. So this is also the second wave equation formula. We call this equation II. Equation II. Now let's derive our third wave equation. Our third wave equation. Now, from this very second wave equation, you see that we have something common in the brackets. We have 2 pi all over lambda, and we have 2 pi all over lambda. What are we going to do? We simply factorize it out. We factorize it out. That means we are going to have our y is equals to a sine 2 pi over lambda bracket vt minus x. Minus x. This is our third wave equation. Third wave equation. Now, still on wave equations, there are other wave equations. Let's derive the fourth wave equation now. Let's derive the fourth wave equation. Now, at the beginning, I told you guys that our f is equals to v. Our f is equals to v all over lambda. This is lambda. So, substitute f equals to v all over lambda in equation II. Yeah, the second equation, which is this one. We substitute f equals to v all over lambda in equation II. No, sorry, it's supposed to be this way. It's supposed to be not substitute f equals to v all over lambda. It's supposed to be substitute v all over lambda equals to f. Sorry, you should be not saying. It should be equals to f. Yeah, this is f. Substitute v all over lambda equals to f. That means when you see v all over lambda, you put f. What are you going to have in these second equations? You're going to have our y is equals to a sine bracket 2 pi. Now we have v all over lambda here. I told you when you see v all over lambda, you simply put your f times your t here, t minus, they just put minus this 2 pi x all over lambda, and this is our fourth wave equation. We call it IV. We are still on wave equations. Now let's derive the fifth one. Now, in this very wave equation, you realize there is two things common. There is something common in the brackets. We have 2 pi and 2 pi here. We simply just factorize it out. You are going to have, when you factorize it out, you're going to have your y is equals to a sine 2 pi bracket ft minus x all over lambda close bracket. This is our equation v. Roman figure v. That's equation 5. Now, listen attentively. still on wave equation. Now substitute f equals to 1 all over t into equation v into equation v. That means you are going to put, when you see that means when we see f, we are going to put 1 all over t, because f is equals to 1 all over period. What are we going to have? We have our y is equals to a sine 2 pi bracket small letter t all over capital letter T minus x all over lambda close bracket. This is our equation 6, which is vi. So now there's a difference between this small letter t and capital letter T. This small letter t represents your time, and this capital letter T here represents your period. So there are two different things. So don't be confused about it. Don't be confused. Now, we are still on wave equation. And also note MB, that our K is measured in radians per meter. Our W is measured in radian per second. So our K is measured in radian per meter, and our W is measured in radians per second. So that's still on wave equation. So now, I told you guys earlier that our W is equals to 2 pi f. If we make f the subject of the formula, what are we going to have? That means we have our W divided by 2 pi equals to 2 pi f divided by 2 pi. 2 pi cancel 2 pi. What are you going to have? Therefore, our f will be equals to W all over 2 pi. Also, I told you guys that our K is equals to 2 pi all over lambda. 2 pi all over lambda. If you want to make, let us make pi and lambda the subject of the formula. We simply cross and multiply. If you cross and multiply, you're going to have our K times our lambda equals to 2 pi. Now you divide both sides by K. K we cancel K here. What do we have? We have our lambda is equals to 2 pi all over K. 2 pi all over K. So you guys can see it. When we make f the subject of the formula here, we have W all over 2 pi. When we make lambda the subject of the formula, we have 2 pi all over K. Now, listen attentively. In the beginning, I told you guys that our V is equals to lambda times F. Now, let's put let me say substitute f is equals to w all over 2 pi, and lambda is equals to 2 pi all over k into this formula, which is actually v equals to pi times f. Listen attentively. Now, when you see lambda, you put your 2 pi all over k. That means you're going to have our v will be equals to 2 pi all over k. When you see f, you put your w all over 2 pi. That means you're going to have w times your w all over 2 pi. What do you notice? 2 pi will cancel 2 pi. Therefore, our v is equals to w all over k. I told you guys this is our angular velocity and this is our wave number. So note all these formulas. When solving equations, all these formulas can be used to solve any wave equations. No matter any question you will give you, as far as you know all these formulas, I bet you're able to solve the questions. Now, we still on wave equation. Let me give you guys some examples, some solved examples. Now, example 1. We have a plane progressive wave. Is represented by the equation y is equals to 2 sine bracket 200 pi t minus 0.5x where the sabers have their usual meaning. Said, what is the frequency? No, let's say what is the amplitude and frequency? What is the amplitude and frequency? Solution. Now, listen attentively. The question says a plane progressive wave is represented by the equation y equals to 2 sine bracket 200 pi t minus 0.5x, where the sebum have their usual meaning. It says, what is the amplitude and frequency? These are questions that you're going to see in your various exams, whether you are in your your first year in your university or second year probably, or you're writing your WAEC or JAMB. So this is the kind of questions you're going to find, and this is the standard question actually. Now, this is what you're going to do when you see this kind of question. They said that they are giving us the wave equation. We said our y is equals to 2 sine 200 pi t minus 0.5x. In this equation, they see that we should find the amplitude and the frequency. Now, the first thing you're going to do, this is what I tell my students, the first thing you're going to do this kind of question is compare it with the equation that resembles this. Among all the equations that I listed before, one of the equations resembles this equation. You simply just compare it. Let me show you guys. You see, we are having 200 pi t minus 0.5x. I think, without even looking, I think it's equation, the third equation, yeah. The third equation, look at it here. Yeah, it's actually the third equation that actually represents it. Yes, the third equation. You can use the third one, or you can use this fifth one. You can use either the third one or the fifth. Let me show you guys very well. So you can use either the third one or the fifth one. So both of them mean both, yeah, they are the same. So, but actually the one I'm going to use, I'll use the fifth equation here. I'll use the fifth equation, the fifth one. But what I'm going to do is, okay, let me show you guys first. You know, in the fifth equation, first of all, let me say, comparing with the wave equation. Now, in that fifth equation, we have our y equals to a sine 2 pi. A sine 2 pi bracket ft minus a sine 2 pi ft minus our x. Let me check if I'm right. Yeah, x all over lambda. Yeah, I was right. Now, you can see that this equation that's similar. For me to make them more similar is, I'll simply just multiply, make this 2 pi go into this bracket. That means I'm going to have my y is equals to a sine bracket 2 pi f t minus 2 pi x all over lambda. Now, in this question, I told you guys what you're going to do. You don't need to solve most of questions. You don't even need to solve anything. You just simply compare it with the wave equation. Now, in the first one, they show us to find the amplitude. I told you guys, your A here is your amplitude. And if you trace it back to the equation they were giving to us, At this position, where do we have our amplitude? Is here. And what is that? That is actually 2. Therefore, your amplitude your amplitude no, it's a thing. I'm making a mistake. Your A, which is your amplitude, which is A, is actually equals to 2 meters. 2 meters. You simply just compare it. Now, the second one, they say we should find our frequency. Our frequency. So now, this is where our F is. This is where our F is. And if you trace it back to here, you see, that means, let me say, if you trace it back to this one, you can see we have 200 pi t. That means that our frequency is inside this 200 here. So you simply just compare this one with this one. Just compare the two formulas together. What are you going to have? We have our 200 pi t, which is this first one. This is this one, is equals to, you're comparing it with this one here, 2 pi f all over t. Why are we comparing it? Because at this is where our f is. If our f is here, that means our f is supposed to be here too. So we are going to simply just compare the two. That's what you're going to do. No big deal. Has it been that our f is at this position, then we are going to use this one to compare it, but our f cannot be in this position. You always be with this one where your t is. So that's why I told you guys to not cramp any formula. Always try to know the basic concept. When you master the concept, when you want to compare anything, it will be easy for you. You don't have to check or which one should I use to compare. No. Once you know that, okay, you have pi t here, and you're seeing pi t here, and your f is here, that means your f also should be here. You just compare the two together. Now, we are finding f. If you are finding f, you are going to make f the subject of the formula. That means you divide both sides by 2 pi t. We are going to have our 200 pi t divided by 2 pi t is equals to 2 pi ft divided by 2 pi t. Our 2 pi t will cancel 2 pi t. T will cancel t. What are we going to have? Okay, something can still cancel here. 2 pi t will still cancel. No, pi t will cancel pi t. So we have 200 and we have 2. 200 divided by 2 which will give you 100. 200 divided by 2 will give you 100. Therefore, our f is equals to 100. Hence, our frequency is measured in hertz. This is Hz. Now, let me go it again now. I simply just compare these two formulas. I compare two of them. Then when I compare, I divide both sides by 2 pi t because I want to make our f the subject of the formula. So when 2 pi t will cancel 2 pi t, t will cancel t out, pi t will cancel pi t down. We are left with 200 and 2. 200 divided by 2 here will give you 100. So that's how we got our 100. Hence, you can see it's very simple and straightforward. In wave equation, what you do is just simply compare it with a formula that matches it. So that will be the end of the class. Thank you very much for watching. Please comment, share and subscribe, and also wait for more videos and for more examples. I will be sending more. Thank you very much for watching. Have a wonderful day.